I am Dr. P.C.Patel, retired research scientist, Anand Agricultural City, Anand. Today the topic of my YouTube is a high quality biochar from Napier grass, waste and stubble, turning agriculture byproduct into a permanent soil sponge for drought resilience and long-term fertility. Your crop are thirsty. The solution is in your waste pile. Worsening droughts, 2026 heat waves are crossing crop yields. Sandy and degraded soil lose moisture fast. Living plant vulnerable. Wasted biomass, Napier stubble, and surplus stocks are often burned or left to rot, releasing carbon instead of locking into soil. Low water efficiency. Traditional soil cannot hold water during dry spells. Every drop is critical for survival of the next harvest. So here you can see that the farmers are buried the Napier stubbles and waste material of the Napier. So super hybrid Napier grass is a ideal feedstock. Stop burning, start building soil resilience. After every harvest, tons of Napier stalks and stubbles remain instead of open burning or inefficient disposal. We convert this worthless biomass into high value biochar. So we have to collect the surplus stalk and stubbles from the field of the Napier grass, then dry and chop. Then third one, pyrolyze, heat in low oxygen condition, 400 to 700 degrees centigrade temperature. Then last one, mix it in the soil as amendment. And we have to apply at the rate of 5 to 10 per hectare, depending upon the soil type. Here you can see that the figure, then the Napier stubbles and the waste material of the leaves and others has been used for the preparation of the biochar. So you can see here the two heaps of the biochar, and it is a machine for the preparation of the biochar from the Napier grass. Biochar, nature's permanent carbon sponge. Biochar is stable, carbon-rich solid produced by heating biomass in a low oxygen environment. Pyrolysis, unlike charcoal made for fuel, biochar is engineered as a soil amendment that lasts 100 to thousands of years. It has high porosity, microscopic pores act like any reservoir, holding water and nutrient for plant growth. Then carbon lock-in, sequestration carbon that would otherwise return to the atmosphere as carbon dioxide or methane gas. Soil condition, it raises the cation action capacity, improve water holding capacity. It is benefit for retention or reduce the leaching losses. So when we are apply the chemical fertilizer, then it minimize the leaching loss. So the efficiency of the chemical fertilizer has been increasing, and we require less chemical fertilizer. Because you know that suppose you are apply the urea fertilizer or ammonium sulfate, then 20 to 25% nitrogen has been lost. But by application of the biochar, we can retention of the nutrient, means we have minimized the leaching losses by the application of the biochar. So what is biochar? Heating biomass in a low oxygen environment, increase soil fertility and water retention, locks carbon in a stable form for centuries. Why Napier grass yields high quality biochar? Lignocellulosic rich high cellulose, hemicellulose, and lignin content create a robust porous carbon scalation, ideal for water retention. Proven performance. Research shows Napier biochar can raise soil water retention by 30% at only 5% weight addition rate. Low ash and sulfur. Cleanest biochar with minimal unwanted minerals, safer for long-term soil application and lower emission. Drought tolerance shows the plant itself thrives with modest water. With biochar inherit the ability to help other crops to do the same. Abundant surplus. After fodder or bio-CNG use, large volumes of stubble remain free or low-cost feedstock every harvest cycle. Dual income stream. When we the farmers are adding the biochar in soil, that they are not only increase the crop productivity, but the farmer get the carbon credit. So the farmer get the dual income from the field. So by addition of the biochar, the crop yield has been increased and also the farmer get the carbon credit. How we convert Napier waste into biochar? First one, prepare, collect dry stubbles of Napier grass, chop to 2 to 5 centimeter in size. The left side the figure you can see that it is a green Napier grass. Then chop, then it is dried Napier grass. So we can dry using the sun or oven dried. Then we have to pyrolysis, give the temperature 700 degree centigrade temperature, partial oxygen. Then it converted Napier grass biochar. So how we convert Napier waste into biochar? So we have given here. Then you can see that it is kiln to make biochar. What makes Napier biochar? High quality, 30% plus increase in soil water retention at 5% addition, high porosity and micropore volume, stable carbon that persists for centuries, clean, low sulfur and control ash content. Additional benefit observed in research, improve cation exchange capacity, better soil structure, enhance microbial habitat, and reduce nutrient leaching, all contributing to higher water use efficiency. The permanent underground sponge, physical storage, biochar internal pores hold water against gravity. Plant can access this reservoir during dry period. Chemical attraction, surface functional groups and high surface area attract and hold water molecules and dissolve nutrients. Improve soil structures. Biochar particles create better aggregation, increasing macrospore for infiltration and micropore for retention. Root zone support. Root explore the biochar soil matrix more easily, assessing moisture deeper and longer into the drought. So here you can see that porous biochar structure, micro and macropore in a biochar, then a high surface area. So you know that 1 gram biochar have 1 football ground surface area. So there is more water retention and more absorption of the nutrient. So cation exchange capacity increasing. So here you can see that nutrient retention side. So whatever the nutrient we applied to the chemical fertilizer, nitrogen or other nutrient that can be not leach in the soil, but it retains and available to the plant. So in short, we are increasing the fertilizer use efficiency and we are reducing the leaching loss, resulted in less pollution of the water. That water we are used for the drinking purpose. Drought proofing plus fertility gains. Higher water use efficiency, crops survive longer dry spell with less irrigation stress. Then second, improve yield under stress. Better moisture plus nutrient is equal to more stable harvest in drought year. So we know that the plant take the nutrient through the soil solution. So if the moisture is not present in the soil, then nutrients are not absorbed by the plant. So under such condition, if we have applied the biochar, then nutrient can be uptake by the plant and we are getting the more production. Third one, long-term soil fertility. Cation exchange capacity boost and organic carbon build lasting productive capacity. Fourth one, reduce input cost, less frequent irrigation, and potentially lower fertilizer losses. So, you know that when we add the biochar, then we require the less irrigation, so we can save the irrigation water. Similarly, when we apply the fertilizer in biochar application field, then there has been less leaching, so we are increasing the fertilizer efficiency. So we are reducing the input cost and farmers get more benefit. Fifth one, carbon sequestration. Permanent carbon sink opens door to carbon credit income. Last one, circular economy. Waste becomes a resource, zero burning, cleaner air, healthier soil. How to use Napier biochar on your farm? Recommended rates: start with 2 to 5% by weight or 5 to 20 ton per hectare, depending on soil types and goals. Sandy degraded soil benefit most from higher rates. Mix thoroughly into the top 15 to 20 centimeter of soil for the best results. So I have conducted the experiment of biochar in 2009 and 10 and again in 2024 on maize crop, corn crop, and we observed that application of biochar at the rate of the 5 ton or 10 ton along with the chemical fertilizer or manure give better performance for the plant growth, dry matter yield of the maize, and also increasing the crude protein content. So practical tips: charge biochar with compost or manure before application for faster microbial colonization. So charging is required with the compost or manure. Then second one, apply once. Effects are long lasting. Reapply only if needed after several years. So you know that when we apply the chemical fertilizer, then it effect remain 4 to 5 months. When we are adding the farmyard manure, then or compost, then it effect remain 2 to 3 years. But when we add the biochar in soil, then it effect remain for longer period. So 5 years, 10 years or more. And if needed, then we have to apply again. Third one, combine with good agronomy, mulching, cover crop, and efficient irrigation, amplify gains. Fourth one, test soil before and after to track moisture, organic carbon, and nutrient changes. So before application of the biochar, we have to take a representative soil sample and see how much nutrient initially are present in the soil. After application of the biochar, you grow the crops. Then after harvesting of the crop, you can take the again soil sample and carry out the soil analysis. Then we can know that how much response of the biochar again the previous one. So we can judge that application of biochar along with the manure chemical fertilizer, we are getting more benefit as compared with control plot. So here on left side I can show how to charge biochar with manure in 3 simple steps. So here it is a manure. Add water to your biochar until it leaks out. Second one, mix biochar and manure in the ratio 1:1. Means suppose you are apply 100 kg manure, then you have to apply 100 kg biochar and so on. Then mix biochar and manure in the ratio 1:1 I told. Then let it sit for 14 days and keep it moist. So you keep it for 14 days and it should be moist one. So here you can see that on right side figures benefits of biochar and compost. So we have already discussed earlier. Turn waste into climate wealth. In 2026, biochar is more than a soil amendment. It is a pathway into growing carbon market and circular economy business. Carbon credit. Stable biochar carbon can qualify for verified carbon credit, generating additional farm income while fighting climate change. So when the farmers are adding the biochar in soil, then they are getting the additional income of carbon credit and also it fighting climate change. Then local production, small kilns or community unit can process Napier waste into scalable biochar for neighboring farmers. Instability, drought, drought resilient soil protect harvest income in bad years, reducing risk for the whole farm enterprise. So you know that when there is a drought period, then the nutrients are not uptake by the plants. So at that time, if we have added the biochar in soil, then it increases the water holding capacity and cation action capacity. So during drought period, the crop will remain stable. Then policy alignment, support national goals on residue management, soil health cards, and climate smart agriculture scheme. What research tells us? Water retention lift. Vacuum pyrolyzed Napier biochar increased soil water retention by up to 30 to 55% at 5% weight addition. Yadav and his co-workers. Surface area and porosity. Pyrolysis at 500 to 600 degrees centigrade produces biochar with favorable pore volume and surface characteristics for soil amendment. Clean carbon. Napier-derived biochar often shows low sulfur content, reducing risks of unwanted emission during production. Broader biochar science. Field studies confirm biochar improve plant available water, root growth, and resilience under drought stress across many soils. Start your biochar journey today. Assess your residue. Measure how much Napier stubble or surplus biomass you generate after residue were measured after 1, 2, 3, or 4 years depending on the variety and soil condition. Choose scale. Start small with a simple scale or partner with local pyrolysis unit. Expand later on. So you start at a smaller scale and then if success then you extend later on. Learn the process, master temperature control, drying and cooling to produce consistent high quality biochar. So biochar quality is very important, and for that we have to maintain temperature, drying, cooling, etc. Trial on farm, apply on test plot, monitor soil moisture and crop performance through a dry season. So the farmer are requested that they can conduct the trial on his farm. Take suppose a 10 kunta lands, then add the biochar at the rate of 5 or 10 ton along with manure or fertilizers. Then keep control also and see how much difference with the application of the biochar or biochar with the chemical fertilizer or manure. So the farmer themselves know that there is a response of the biochar over the control pot. Then scale and monetize. Once proven, expand production and explore carbon credit or local biochar sales channels. So if the farmer prove that and confirm that the application of biochar in the soil give benefit, then they expand production and explore carbon credit, apply for the carbon credit or local biochar sales channels, or they can produce and sell to the farmers. Biochar from Napier grass, proven by research, scientific studies in India and globally, confirm successful production via pyrolysis. India, key studies, Yadav and his co-worker, 2016, vacuum pyrolysis of Napier grass, Pune source, Maharashtra, biochar for soil amendment and adsorption, resource efficient technologies. Yadav and co-worker, 2024, pyrolysis at 700 degrees centigrade Delhi source, sustainable biochar for dye removal process, journal MDP. Hybrid Napier from Tamil Nadu Agricultural University, Coimbatore, used in multiple carbonization studies. So similarly, globally also we carried out the research work on the biochar from Napier grass to biochar, benefits and application, soil amendment. So you can see that improve water retention and fertility on degraded drought-prone soil. Product and growth, high quality porous biochar support healthy plant establishment. Third one, process concept, Napier biomass, porous carbon structure that retains water and nutrient. Means it increase the water holding capacity and cation exchange capacity. So confident conclusion, multiple peer review studies, India, Pune, Delhi, Tamil Nadu Agricultural University, global, Brazil, Nigeria, Australia and others, demonstrate that high quality biochar can be reliably prepared from Napier grass and similar grasses through pyrolysis. These support commercial and field-scale production for soil health and carbon sequestration. Bridge the gap between waste and resilience. High quality biochar from Napier grass waste is practical, science-backed way to lock moisture into soil, boost fertility, and create new income streams for Indian farmers facing drought. My name is Dr. P.C.Patel, retired research scientist, Anand Agricultural University, Anand. My WhatsApp number +91 9909022116. My email patelpc12@gmail.com. Subscribe for more soil health and Napier guidance. Turn waste into wealth. So if you want more information related to biochar, soil health, or bio-CNG based Napier grass, So you know that for the production of the biochar or bio-CNG or biopellet, we should have to produce more Napier grass production per acre. So for that, we have to first look the soil health. Then accordingly, we should have to apply the nutrient in soil. So I did the work on the biochar also. So thank you very much.